All right, and so we're going to start off with the homework problems, and the first one just says, for each variable, think about the following numeric variables and report an approximate measure of central tendency and state whether you expect the distribution to be symmetric, positively or right skewed, or negatively and left skewed. Okay, so, and I provided an example, and I hope that made sense about the annual household incomes in the U.S. And so the first one, so problem 1A. So if you guys are following along with your homework, feel free to mark it up and say, this is where I got something wrong, and pay attention to if the things you did is different from what I'm doing, okay? And that maybe you can see where there might be a disconnect in our understanding. Okay, so the first one said arm span of adult males in the United States. Okay, arm span of adult males in USA. All right, so I said approximate measure of center. What do you think the approximate measure of center would be for arm spans of adult males in the U.S.? Okay. Yeah, it was just a guess, okay? Just to get an idea, okay? So some of you said 68, 69, and I'd say those are very good guesses, okay? Because, if you just think about how wide an adult male, how wide the arm span is from fingertip to fingertip, it's going to be around 5'10", around somewhere between 5.5 and 6 feet tall. So I would say any number in between 66 and 70 or something like that is a great guess. So I would say approximate measure of center. I'm going to say 69. Okay, but if you have something similar, bigger, smaller, that's fine. Okay, but if you think the I'm just hoping nobody put something like 35 or 100 or something, You didn't understand the question. Okay. Okay. Yeah. This is all I wanted you to do was just think of a number, stretch out your arms and just say, "Oh, how wide is this?" Okay? And of course, I'm not expecting exact answers, but just think, "Okay, well, what do you think the average this is?" That was what I was getting at. Okay?
Will the female be shorter?
Yeah, the female arm span will be shorter. So, if in general, the average height of females, or not in general, this is the truth, average height of females is lower than the average height of males. Of course, any given individual, there might be a tall female and a short male, but overall the average is that women are shorter than men, on average, okay? So that would be the approximate measure of center. What about the shape? Symmetric, right? Okay. Let me not that. Let me yes.
Can we mark on our homework?
Yes, absolutely. Please do. The homework is for you. It's not for me. I don't care so much. I mean, I shouldn't say that, but no. I'm going to collect it and make sure you've done it, okay? But the homework is for you guys to learn.
Will these be on our test, the first test, our homework accumulation of
I haven't decided what exactly is going to be on the test. So let me just thin down our pen here. So the homework is for you to learn. So that's the most important thing for me. I want you guys to learn as you do the homework. Some of you guys have typed up your homework, and that's great, but it's not required, okay? I'm not going to give you more points because you typed it up versus handwritten it. I just want to make sure you guys are doing the homework, and most importantly, I want you guys to learn from the homework. And whenever you face a problem where you don't know the answer, or you get stuck, okay? I want you guys to do your best, okay? I want you to think, read the question and say, what is this question asking? What do you think is going on here? And do your best in answering it. A lot of times, when you first read a question, it's going to be confusing, and you'll say, I have no idea what this guy's talking about. And that's okay, you know? But you read it again, and maybe you'll say, oh, I think I understand what he's trying to get at. And your brain learns that way, by facing challenges and trying to work through them, okay? If every time you just faced a challenge and you said, I give up, you're not going to learn. You're not going to improve and grow your mind. So anyway, that's my rant about how we learn and why hard homework is better than softball easy homework, okay? All right, so let's talk about the number of traffic tickets a driver in Los Angeles County has received. Yes, question. How do we know the shape is symmetric?
Some arm span may be long and some may be short, but majority has the average.
Yeah, okay, so that's a very good answer. So some people will have long arms, right? LeBron James, I'm sure his arm span is huge, okay? Some people have short arm spans, like CeeLo Green on the The Voice. Have you ever noticed? It seems like he has short arm. I mean, I don't know. I haven't measured his arm span, but if I had to guess, his arms seem... okay, anyway. What's that? I don't know. I don't want to say anything but that. You know, talented artist, but maybe short arms. I don't know. Okay. But yeah, but most people will have average length. And I would imagine if we think about how many people have really long arms versus how many have really short arms, we would probably see about an equal number in terms of, so that's why we're going symmetric. Remember, right skewed means you can have really, really high numbers, but not small numbers. So if arm span were right skewed, we would see, not very often, but sometimes we would see people with 10 feet arms, and that just doesn't make sense, right? So, and left skewed, or... so symmetric is the idea that large numbers are just as common as small numbers for symmetric, okay? I wouldn't say the same, but equally common, okay? So symmetric means large numbers are equally common as small values, and vice versa.
Okay. Thank you.
Okay. So yes, if you get stuck, you know, do your best, but then put question marks and say, I did my best, I'm not sure if I did this right, and ask those questions in class the following week. I'm happy to answer these questions. Okay, number of traffic tickets. A driver in LA County received, right? Okay, so what do you think an approximate measure of center is? What do you think? So I guess I didn't define a time frame. Okay, all right, so if I guess I did not define a time frame, so this part I guess was left open to interpretation. So if we said in 1 year, then probably the average number of tickets someone receives in a year is probably 0. Okay, maybe, or if you wanted to, you know, that would probably be the median, or definitely probably the mode. I would say over half of drivers probably get 0 tickets in a year. What do we think? Does that seem reasonable? Yeah, but I mean, if we think of all, you know, all the drivers, I would say probably more than half can manage to get through a year with 0 tickets. So I would say approximate measure of center is 0. But if we want to talk about maybe, so this would probably be the median or mode if you want to be specific.
0 would be the median?
Yeah, I would say 0 is the median or mode. And if we're talking about the mean, maybe 0.4. I'm just making up a number, okay? But this would be something like
0.4 would be what?
the mean. And I'm just making up a number, but that seems reasonable in my brain. I have no idea, okay? Yeah, we don't know, okay? Just an approximate measure of center is all I was going for, okay?
So there's really no right or wrong on this answer?
Okay, so I would say any number 1 or smaller, 1 or 0, I would say is good, okay? But if you put 10, I would say maybe we should talk about your driving habits, okay? If you think that's the average number of tickets or approximate, okay? What about the shape? Right skewed or left skewed? So I'm going to say right skewed, right? Right. So probably most people are around 0. Okay. Do you think there are a few drivers in LA County who get over 5 tickets in a year? Yeah, certainly, right? I mean, there's always somebody on the freeway, and we're like, I hope you get a ticket today. You know, the way you're driving. Sometimes we probably shouldn't wish bad things upon others, but sometimes we do. But some people may have 5 tickets. Who knows, 5 tickets or more. Their license might get suspended if you get 5 tickets in a year.
Can you do that problem with a graphic, the number B, to see how?
So I'm just making something up, and so I would say most people get 0, some people get 1 ticket, but probably not very many people get. So this would be 0, 1, 2. In terms of 3, 4, and 5, probably very few people. So I mean, this is my poor histogram here. And so if we're talking about shape, this would be right skewed. Can anyone get less than 0 tickets in a year? No, it's not possible. Okay, so definitely right skewed. Okay, is that good? Can I write in this zone with this tape here? I don't know who put the tape on the screen, but what's that? Yeah, I don't. It was kind of, they gave me a little bit of a hard time moving the classroom into here, so I don't want somebody to complain that I peeled off their precious tape on me. It was there for a reason. Okay. All right. So the number of children an adult woman has given birth to. Children born to an adult woman. All right, what do we think the approximate measure of center? So something like the mean or the median. Yeah, probably around 2, something around 2, maybe a little more, a little less, okay? But in order for our population to be self-sustaining, women are supposed to have 2 children each, right? Because to replace themselves and to replace the man who cannot give birth. So, and so in countries that show population growth, this approximate measure of center is higher than 2. So in the United States, we're probably around 2.3, 2.4, and so our population is growing steadily, and we also we're an attractive country for people to move to, and so we also grow in that way. Other places, such as many countries in Europe and Japan, the number of children being born to women is less than 2, and so they are seeing population decline. Okay, so there's great worries about the future of their equivalent to Social Security or retirement pension funds, because as fewer children are born and the aging population grows, then it's a greater burden on the young people. Yes.
When you say the approximate measure of center, are you referring to
Yeah, central tendency. So this approximate measure of center is kind of a fill-in word for either the mean or median or mode. Okay, any of these would have been acceptable as an approximate measure of center, especially with the mean and the median. Okay, so if you want to say 2 or 2.2 or whatever, anything around there is fine. If you said 5, we're probably, I think in Ireland it's maybe around 3.5 or 4. It's very high comparatively to other countries. Is this okay with everybody? All right, and then the shape also is going to be right skewed, right? And so if we draw a graph here, probably not that high, but a good number would have 0, quite a few would have 1, a lot would have 2, and then some would have 3, and then as you get larger than 4 and 5, you probably have fewer and fewer and fewer. But we probably all know someone who has 6 kids or something.
Sorry.
Yes.
From where did you get the number 2?
I'm just guessing. It's an estimation, okay? I'm not asking you to look up, do research statistics, go into the almanac and look these things. I just wanted you to think about this and just say, oh, if I had to think of a quote an average number for this, that's what I wanted you to do. Okay, so a lot of statistics is kind of just guessing, not literally guessing, but it's good to think of a number, think of a variable, and think of what are reasonable numbers that we would see for this variable. Okay, because a lot of times when you do math in statistics, a lot of it should pass these common sense checks, right? If you're solving for this and you take your data and you're getting the approximate measure of center to be 5, something in your brain should say, that doesn't sound quite right, and you should go back and check your work. Yes?
Okay, I'm a little confused because our first class, I was using the example that you said there's no such thing as 2.2 kids or 2.5 kids. So I thought there were going to be whole numbers, and let's say it would have been, my guess would have been 3, then you're saying that it would have been fine still because it's next to 2 and it's an average? Or?
Okay, so this is a very good question, and let me clarify what's going on here. So this is LA County, May 18th, 01. Okay, so for number of children born and number of traffic tickets, you're right. For an individual person, you can only get a whole number. You can't get 2.2 children. Nobody can have received 3.4 traffic tickets. That's correct. But when we are talking about the mean, okay, the mean is where we add up all the numbers and divide by how many numbers we have. Okay, and so if we're talking about the mean, it's okay to get a decimal. And we can kind of understand that, right? We can, if I say the average or the mean number of children born to a woman in the United States is 2.2 children, we can understand that, right? We can understand that a lot of women have 2, but some have more than that. And so when we take the average across all the different women, we're going to get a number like 2.2. Okay? But in terms of an individual woman, if we ask her how many children do you have, she can only answer a whole number. Okay? So I hope that makes sense.
Yeah, it makes sense. I just still didn't see the average amount of women. I mean, the question is there.
So I just said approximate measure of center, and that I left open to interpretation to you as whether you wanted to state the median or the mean. So
you're stating the.
So if you answered 2,
would be the mean, right?
2.2 would be the mean. 2 would be like the median or the mode. Okay? Is this okay? All right. How do we do on these problems on our own? Pretty good, right? So these ones were okay. Good. All right. So let's go on to the next problems, the ones that probably gave us maybe a little bit. So I'm going to just take some time and copy these numbers over. 20, 38. These were test scores. 45, 51, 61, 64, 69, 71, 74.
75.
Great. Okay. All right. And I'm still going on. 79, 79, 80, 80, 81, 81, 86. So
88, 90, 90, 92, 92, 94, 94, 97, 99.
okay. So we can imagine these being 30 test scores, right? So, you know, a lot of students got 70s and 80s and 90s, okay? And a few students did poorly. 60s and, you know, one student got a 20 and, you know, we don't know what happened that day, but this is just what it says, okay? So A says find the median score, okay? Were we able to do this?
Yes.
Okay, and what do we get for the median? 80, right? The median is 80 because there are 30 test scores, so we find the spot where half are bigger, half are smaller. So we count 10, 11, 12, 13, 14, 15. So I can draw a dotted line. So actually, let me, for the next slide, let me just copy this. Okay, so if I draw a dotted line here at 15, okay, I'm going to have 15 numbers bigger, 15 numbers smaller, and so we get the median to be 80. Okay? No problem there, right? Okay. Then it says make a frequency table using bins of size 10. For example, that is 0 through 9, 10 through 19. Okay? So I'm going to create bins here. And was this part okay? Okay. All right. Good. Yeah. Absolutely. You should probably look at your notes because I'm not expecting everybody to have everything memorized the first time they see it. But we're going to go bins 0 through 9, 10 through 19, 20, 30, 40, 50, 60, 70, 80, and 90. And then on the other side, 29, 39, etc., etc., etc. Okay? Do I have to fill all of these out? You guys get the picture, right? Okay, and then so we count. How many are in 0 through 9? 0. Okay, 0. We get 1, 1, 1, 1, and then 3, 7, 8. And what was that? 8. Okay. Great. Okay. Perfect. Everybody got this? So that's great. Okay, I'm very happy to hear that. And then it says make, using the frequency table, make a histogram. Okay, and so let me see. We'll go up to 100, 90, and I think this part was probably okay for all of you too, right?
Yes.
And then you have the frequency, and so you just mark off 1, 2, 3, 4, 5, 6, 7, 8 or something, and you get bars like. So I'm just doing kind of a junky job here. I'm sure your bars look much prettier than mine here. Of course, right? I'm certain everybody. Okay. Something like this, right? Okay, so there we go. And everybody's good there. Okay, describe whether this data is right or left skewed or symmetric. So we say left skewed, okay? Okay, any questions so far?
More to the right?
Because the pointy end, if we had to summarize this with a curve, we would say it looks something like this, right? So the pointy end, the skewer, if you had to use this as a weapon against some meat that you were going to grill, you would stab it with the left side, so that makes it left skewed, okay? And again, the idea behind left skewed is you can have values. So if we had to think of what's the average test score, we said something around 80, okay? And we can have values much lower than 80. Somebody's down at 20, right? So that's 60 points lower than 80. Can we go 60 points above 80? No, because that would take us to 140. So left skewed means you can be much lower than average, but you can't be that much bigger, right? So 20 is 60 points below the median. but we cannot go 60 points above the median. Is everybody able to read? Let's see, we're good? This is how when I teach at UCLA, I use the screen like this, and I hope you guys like it. So I'm hoping next week everything with the projector will be ironed out, and we can be in that classroom, and we'll go that way. Okay. Again, thank you for your flexibility with today's chaos.
Are we off next week?
I'm sorry?
Are we off next week?
Yes.
Yes, next week is Memorial Day holiday.
No.
Huh? Yeah. All right. Okay, so we're gonna go on, and I have these same set of numbers right here. And so part E says the mean of the above test scores is 76.5. So the mean was 76.5, and we found earlier that the median was 80. Okay, so how does the value of the mean compare to the value of the median, larger or smaller? So the mean is smaller. And do you guys remember what I said about the mean being smaller than the median? Okay, so when the mean is smaller than the median, it's an indicator that the data is left skewed, right?
Left skewed?
Mm-hmm. And does that match what we saw in the histogram?
Yeah.
Absolutely, right? So matches what we saw in the histogram. Are there any questions on this?
So on that one, if it was larger, then it would be right skewed?
Yeah, if the mean was larger than the median, it would indicate that our data is right skewed, okay?
So how would you get symmetric?
The mean and the median would be like the same value. You'd have the mean being something like 80, and the median would also be 80. Maybe they're off by a decimal point, 80.1 versus 80 or something like that. But, 76.5 is, I don't know if significantly is the right word, but it is smaller than the median, and that would indicate that.
So if it was right skewed, would the mean be higher?
Yes. If the data were right skewed, we would expect the mean to be something like 83 or 84, okay? But we would be confused if that were to happen because so if the mean is larger than the median, it indicates that the data is right skewed. But that did not happen here, okay? When we saw our histogram, we definitely saw our histogram looking something like this, right? Which was, left skewed, okay? So our histogram, it definitely indicated left skew. Our mean and median compare in such a way that it's also left skewed, okay? So this is just to show that these summary statistics indicate, work together with our histogram. Okay, and let me just take a look here. Okay, what was the range of these scores? Okay, yeah, we just did 99 minus 20. We got a range of 79, okay? How did I get that? So the range is the maximum value, max value, minus the minimum value. Okay, so what's the largest value I have? 99. What's the smallest value I have? 20. And that's how we get the range, 79. That's all. Okay. Okay, so maybe I did that too quickly in class last time or something. Some of you guys might have missed that. Okay. So, or maybe it was in your notes. It should have been in your notes. Okay. All right. So some of us got in on our notes and others of us missed. And some of us didn't. Okay. And that's okay. All right. And lastly, find the IQR. So this one was probably the most involved one. Okay. And so, yeah. Okay. All right. So the step for finding the IQR is basically imagine cutting a sub sandwich into quarters, right? First, you cut it in half. And then once you have each half, you cut that half in half again. That's what we're doing, right? IQR is interquartile range, so think of quarters. How do you get quarters? Cut it in half, take each half, cut it in half again. So you've already found the median, and nobody seems to have trouble getting the median here. Okay? So now I'm going to take this half, 20 through 80. Okay, how many numbers do I have? 15. I want to cut that in half. So how many will I have smaller and how many will I have? So 15 divided by 2 is 7.5, right? Okay, so I'm going to count to here. I'm going to go 1, 2, 3, 4, 5, 6, 7. And then this is the 8th number. Okay, so when I say 7.5, I'm supposed to quote unquote cut this number in half, and I would have 7.5 smaller and 7.5 larger. Of course, we can't do that. So this number itself becomes the halfway point, okay? And so now I have 7 that are smaller than 71, and I have 7 that are bigger than 71 up to 80, right? So if I count here, I have 1, 2, 3, 4, 5, 6, 7. So 71 is my, what do I call this number? Q1. So Q1 is equal to 71. Was that process okay with everybody? Yes? Right now it is?
Yes.
Huh? Okay, well, okay, so if some of you, huh?
You went to 20 to 80?
Yeah, from 20, because, right, I have 30 numbers, and when I found the median, I split it in half right here at this point, okay? And now I'm taking this half, and I'm cutting that in half, and I'm getting there, okay? So some of you guys, I know you guys got it in the homework, but if you didn't, try right now to get the half or the Q3 of the upper half. Don't shout out your answer, okay? Just do it in your head. Find Q3. Okay? If you were unable to do it in your homework, now's a good time to practice and see if you can get Q3. I'm sorry? So remember how we got Q1? How did we get 71? What did we do? Yeah, we cut the half of this half, okay? So to get the upper quartile, the Q3, we're going to take this half, 80 to 99, and cut that in half. Okay? So I'll give you guys a few seconds to get that. Okay, and what did we get for Q3? 90, right? So I count 7, 1, 2, 3, 4, 5, 6, 7, and this is my Q3 because I'm going to have 1, 2, 3, 4, 5, 6, 7 also. Okay, so that's just a good check. You want to make sure you have the same number above as you have below. Yeah, half of the 15 numbers. So our Q3 is 90, our Q1 is 71. IQR is Q3, Q3 minus Q1, I get, 19. I'm doing my math wrong. There we go. And again, look at your homework, mark it up. All right. I'm going to take a look at your homework today during the break or what that we take, and then I'll allow you guys to take it back, okay? Because I'm really just checking to make sure you've done all the problems. It's very quick for me to check. I'm not going to check individual answers to make sure you answered every single number correctly, okay? that's your responsibility during this time as we're going through the homework.
And that made it easy because the total numbers is whole number. If you had like 31,
Okay, so 31, we would do,
it still would be half and half.
yeah, so what you would have at 31 is you would have 15 and a half, so your median would actually be one of the numbers. So in this case, when we had 30, our median was between two numbers, okay? But at 31, your median would be one of the numbers, and you would have 15 below, 15 above, right? Okay, and then, I'm sorry? And then at that point, you're going to get the Q1 and Q3. Now you just treat, so if I tacked on, let's say, so don't bother with this, okay? But let's say I tacked in on the number 100 here, right? So now I have 31 numbers, so then my median becomes 80, okay? Can you guys see that?
Yeah.
All right, so let me just use a different color here to just keep track of everything.
It's actually 60.
Yeah, so my median becomes 80, and I have 15 numbers bigger than this 80, and I have 15 numbers smaller than this 80, okay? And then now I find the median of these 15 numbers, and I find the median of these 15 numbers. And so Q1 stays the same as 71, but then Q3 becomes 90, okay? But don't worry about it. You don't have to put that in your notes or anything like that, okay? But that's a good question. Is that process okay? If you were to face this problem, like if I gave you a bunch of numbers and I said find the IQR on a quiz or test, can we do this? We all feel good? Okay, great. If you do it right now, of course, okay? Yeah, in a couple of weeks, okay? All right, so it said the standard deviation of the above scores is 18.3. So let me actually let me get these numbers, okay? So this problem, maybe you read it and you're like, what are you talking about, okay? Totally fine, okay? But as we read it, I hope we're able to make sense of what the question was asking, okay? So it said the standard deviation is 18.3, and the question says, what is the interval that is defined by being within one standard deviation of the mean? Okay, that's what we want to know. Okay, well, we see two things in here that should have numbers, right? We have standard deviation, one standard deviation. So for standard deviation, we know the standard deviation is 18.3. And do we know the mean? Yes, 76.5, right? 76.5. So I purposely gave you these values because I know you can find the mean yourself. You can punch 30 numbers into your calculator, add them up, and divide by 30. But I thought that's kind of a waste of your time to do that, okay? And, if you can find the mean of 5 numbers, you can find the mean of 10 numbers, you can find the mean of 100 numbers, but chances are when you do it for 100, you're going to make a typo somewhere along the way, and all of your work goes down the tube. So, and the standard deviation, you can calculate it by hand, but we didn't cover that, and it's not even worth getting into right now, okay? So being within one standard deviation of the mean, so we want to know what does it mean to be within 18.3 of 76.5, okay? So for example, you guys probably hear things like this. If you go to the doctor's office and maybe you get some lab work done, they'll say, oh, your blood, this is, 150 or something. And you go, well, is that good or bad, And they say, oh, well, generally we want you to be within 30 points of 140 or something like that, okay? So that's essentially all we're saying here. What does it mean to be within a certain value of another value? So if we say we want you to be within 30 points of 140 for blood whatever, that means any number between what? 140 minus 30, which is 110, and 140 plus 30, which would be 170, is an okay number. So if you're between 110 and 170, blood work, we would say you're okay. If whatever, I'm making up these things. So that's all we're saying, okay? We're saying, what does it mean to be within one standard deviation, okay? So we want to be within 18.3 of 76.5. So my lower end, I'm going to do 76.5 minus 18.3. And what will I do for my upper end? I would add them. That's all, okay? Does that make sense? Okay, and so does it now make sense to say being within one standard deviation of the mean? Okay. It makes sense, maybe? All right, and so, huh? So one standard deviation. So let me just do 76.5 plus 18.3, and I get 94.8. And on the other end, I do 76.5 minus 18.3, and I get 58.2. Okay? What if I said be within 2 standard deviations? So what if I said that instead? What does that mean? So we would do 18.3 times 2, right? So 18.3 times 2 is equal to something else. 36.6. And now we want to be within 36.6 of 76.5.
I'm sorry, I have a question. I must have lost it somewhere. Where you got that 76.5, where'd you get that from?
That's the mean.
Oh.
And that was presented earlier on in problem 2, part E. Okay? In 2 part E, I gave you the mean, and so the mean is 76.5.
And the 18.3 would be about.
I also gave you 18.3 in problem 3. I said the standard deviation of the above test scores is 18.3.
So the 2, so you could go higher and higher with the first.
Yeah, if you say, what is it to be within 3 standard deviations and 4 standard deviations and things like that, okay?
Well, we ever have to find the number that you're given? Like
The 18.3 and the 76.5, I'm not asking you to find that by hand, okay? We could get into it, but in my experience, it's a lot of, it's tedious, and it's like your brain space is valuable, right? So it takes up a lot of brain space for something that's not super useful, in my opinion. Finding it by hand, we normally just ask the computer to find it by hand. Yes?
So if we with the 2 standard deviation,
Uh-huh.
we need to deduct
Yes, we would do
36.6 from the mean.
Yeah, we would do 76.5 minus 36.6, and we would do 76.5 plus 36.6. Okay? And we would get something else.
What is that question in the number 8?
This is 3A. What does it mean to be within 1 standard deviation of the mean? It basically means we want to be, so for 3A, our answer is we want to be between 58.2 and 94.8. Okay, that's what it means. Okay, what does it mean? What is the interval that's defined by being within 1 standard deviation of the mean? We want to be between 58.2 and 94.8. Is that okay with everyone? No?
So we always need to minus and plus?
Yes, so so just ignore these numbers. If I say we want to be within, I don't know, let's say, you're trying to, fit something into, I don't know. I'm trying to think of an example, okay? But we might say, oh, we just want you to be within 20 points of 100. Okay, if I say I want you to be within 20 points of 100, that means what values are okay? Any value between what? 80 and 120. Does that make sense? If I say I want you to be within 20 points of 100, okay?
You have to add the 20 and subtract the 20.
Yeah, you add 20 to 100 and subtract 20 from 100. Okay? Does that make sense?
So the answer is between 80, it's not a specific number?
So I'm saying I'm basically saying we want to be within 18.3 of 76.5. I've just changed the numbers. So I'm doing, to get the bounds, I'm getting 76.5 plus 18.3 gives me 94.8. 76.5 minus 18.3 gives me 58.2. Okay?
If you saw that question again, would it always actually like be over again?
Yeah. Well, okay. So let's answer the next question. And I hope this makes sense. Okay. What percentage of the data is within one standard deviation of the mean? Okay. So to be within one standard deviation of the mean, we want to be between 58.2 and 94.8. Okay. And we want to know which numbers are within one standard deviation of the mean. Okay. Is 20 between 58.2 and 94.8? No. What about this? 38. No. Okay, so what numbers? Starting at what? 61. So I'm going to put little check marks here. So all of these numbers are within one standard deviation. Okay, all the way, all of these numbers, all the way up to 94, 94, 97, and 99 are not, right? So, okay, let's count how many numbers are within one standard deviation of the mean. Okay. So I get 1, 2, 3, 4, 5, 6, and I count all these 16, 17, 18, 19, 20, 21, 22, 23, 24. Is that okay? So for part B, 24 of the numbers are between 58.2 and 94.8. 24 of the numbers are between 58.2 and 94.8.
But 61 is more than 58.2.
That's correct.
Yeah.
Is 61 between 58.2 and 94.8? Yes. That's all that matters. It's just, let's say you wanted to become an astronaut, right? Or you wanted to be a jet pilot. No, okay, nobody wants that, right? But let's say you did. As a kid, you wanted to be a jet pilot, right? Well, in order to get into the jet, you cannot be too tall and you cannot be too short. And they say, okay, you've got to be between, 5'10 and 6'3 or something like that. Okay? Can you be taller than 5'10? Yes, as long as you're not taller than 6'3. That's all we're saying. Okay?
So higher than 58.2 and then lower than 94.8?
Yes, that's all we're asking. How many numbers are between those two values? 24 of them. Okay? And I asked for a percentage. So what percentage of 30 is 24? So for the percentage, I'm going to do 24 divided by 30, and I get 80%. 80% of the numbers,
What is the question? La answer for the
80% of the data is within one standard deviation of the mean.
You did 24 over 30?
Okay, how many data points do I have?
30.
I have a total of 30 data points. Okay, so we're asking what percentage of the data? 24 out of 30 gives me 80%.
But in the letter A, we don't have a specific number. If the answer is we want to be between 58.2 and 94.8.
I'm so sorry. So
The letter A, we don't have a specific number for the answer.
it says what is the interval, right? So an interval is from a low to a high. That's an interval, right? So an interval, you think of I don't interval training or something. I don't know. Basically, from a definitely begin to an end point is an interval. Okay, if there's a start and an end, that's an interval. So our interval starts at 58.2, ends at 94.8. We are all heard this word interval? Okay.
So 24 would be the interval number?
No, 24 is how many data points are within the interval.
I get that.
Yeah.
But I'm trying to label.
There's no label for this other than 24 is the number of points between 58.2 and 94.8. Okay? Yes. Yes. Okay. Well, I mean, another way we could have done it is we could have just counted how many are not. All right, and we say, okay, well, these are not in our interval, and these two are not. So we have 6 data points that are not in our interval, which means how many are within? 24, right? If 6 are not within, 24 must be within. So that's another way to do it. Okay?
And the number 80%, how do we get it?
I did 24 divided by 30. So if I go on the calculator and I do 24 divided by 30, and I get 0.8, and 0.8 means 80%, right? Okay? All of these are multiple steps, right? Okay. Okay, let's say another class took the same exam, and there were 25 students in this other class. Okay, the scores of these students have a mean of 83 and a median of 85. So let's do problem 4. Okay, so other class has a mean of 83, median of 85, and number of students, n, is 25. Okay, and what about our class, or this class that's described?
30.
Okay, so we have 30 students. What was the mean?
80.
No, the median was 80. The median was 80, and the mean was 76.5. Okay, so if we had to compare performance from the other class versus our class, what would we say?
They did better.
They did better. Okay, their scores are higher on average. Okay, it doesn't, that's all it says. Okay, we don't know about the individual scores. Maybe there were individual star performers or poor performers in the other class. We don't know. But just from the summaries, comparing mean to mean, this mean was higher than this mean. This median is higher than this median. Overall, their scores are higher on average. That's all I was looking for number 4. Okay? Okay. And other class, the range is 45. The IQR is 17, and the standard deviation 11.45. What about our class? What was the range? 79. The IQR 19, and the standard deviation 18.3. Okay, so these are all measures of spread. Okay, so what can we say about the spread? Spread of the other class? Okay, if we compare ranges, other class is what?
Less.
Smaller, right? Our class for IQR, also less. Standard deviation, also, right? So, we have this and this for these. The ends don't really matter for comparing means, but over here, so the spread of the other class is consistent, is smaller, right? For all 3 of our spread measures. Is smaller for all 3 ways to measure spread. So we have 3 ways to measure spread, and for all 3 of them, their spread values were smaller. So what does that mean? So overall, their spread is smaller, okay? Spread of the other class is smaller. What does that mean? I'm sorry? So it doesn't mean that's skewed right. It just means in terms of the scores that we saw in their class, they were much more consistent in their performance. Okay? So in our class, we had, top performing student was a 99, lowest performing student was a 20. Okay? We looked at the standard deviation. There's a lot of spread, meaning not everybody scored the same. Some scored higher and some scored lower. And 18.3 is kind of a way for us to summarize how much spread there is. Over here, the way we summarize the spread, we give it a value of 11.45. So, meaning most people their scores are more similar to each other. Okay, so the scores in the other class are more similar to one another. Okay, so less diversity in the scores. Less variation or less diversity in scores.
So that's just saying that, it would be, there's a sense that it would be more symmetric.
Not necessarily. So these things doesn't tell anything about the shape. Okay, so just think of it this way. Okay, so in our class, the one that had 20 through 99. Okay, if let's say somebody from the administration said, you know what, I want to interview one of your students and get an idea of how your class is doing. Okay, as a teacher, you'd be nervous about who they're going to select. You're saying, I really hope they pick one of my star students because the star students are way better than my bottom performing students, right? And you'd be kind of nervous about that. But in this other class where there was less spread, you would be less nervous. Of course, you want your better students to be selected, but if they picked a lower performing student, it wouldn't be as drastic of a difference as the top performing student because your spread is less. So you're saying, so in the other class, the best performing student and the lowest performing student aren't super different, okay? If you're getting a better student and a worse student, they're not crazy different, okay? Over in the other class, your highest performer and your lowest performer are drastically different, okay? So, does that make sense? Okay. Okay, good. We'll write that down then, okay? Your best performers and worst performers are not drastically different. So, and in different situations, we may or may not want large spread, okay? So large spread makes exciting games of chance. So you go to Las Vegas, you see flashing lights that say, like, if you play this slot machine, you might win $100,000. Okay, so there's a huge spread in the amount you can win at a slot machine. Most of the time, you win zero, right? Okay, now, but what do you think would be a more popular game, right? You go to a casino, and the slot machine says, "Oh, put in a quarter, and you might win between 20 cents and 30 cents." Do you think that's going to be a popular slot machine? No, no one's going to be. You'll say, "Oh, I put in 25 cents and I won 20 cents, so I guess I shouldn't feel too bad." But that's going to be a very boring game, right? You're going to just be punching, and you're like, "Oh, I'm going up a nickel or down a nickel." That's not very exciting. It's much more exciting to say, "Oh my gosh, I have a chance at $100,000." So large spread makes for exciting games. But when you buy a car, in terms of how much you have to spend on repairs, you don't want large spread. You would much rather buy a car and say, I know every year I'm going to have to spend around $200 on repairs, and just say that's the price of driving my vehicle. And I think if they could guarantee you're going to spend between $150 and $250 on repairs every single year, you'd be pretty happy with that, right? But on the other hand, if somebody says, oh, their cars, if you get a good car, it's great. You pay $0 in repairs. But if you get a bad car, you're going to have to pay, $2,000 in. You might pay, $10,000 in repairs. Nobody would want that car because that would be a sign of poor craftsmanship and things like that. So large spread, different low spread gives us a different idea of, kind of consistency in our numbers. Okay, so that was the review of our homework. It took us about an hour, and we got off to a late start, so we're at 2:30. Okay, so I will put this, I'm recording my screen here, and I'll post this video online on our class website. You can take a look at it on your own time if you want to ever review any of these problems.